if you know f prime, what you're doing is you're trying to figure out where f prime is positive or negative. Does that make sense? And these are synonymous, so make sure you understand this. Anytime f is increasing, then f prime is positive. If they're on the same row, they're synonymous. Does that make sense? Anytime f prime is negative, f is decreasing. Okay, make sure you understand those are synonymous. Okay, so here's the first question. Where is f decreasing? Where is f decreasing? Okay, so f is decreasing when f prime is positive. No, negative. Sorry, negative. Okay, so so let's look at this. Where is f decreasing when f prime is negative? Where is f prime negative? Like from what x number to what x number? From A to B. Is everybody good with that? Why? Because f prime negative is not the same as f prime decreasing. Are you guys good with that? Okay, decreasing and negative are not the same. Okay, so f is decreasing when f prime is negative. I have f prime here, so I go look at my picture. Charles, you with me on this? I go look at my picture, and I find where f prime is negative from A to B. So the answer here, let me ask you, where is f decreasing? The answer is going to be from A to B. Okay, here's the other question. List the intervals where f is increasing. Okay, so from my first derivative test, I know that f is increasing when f prime is what? Positive. So where is f prime positive? At what time is f prime positive? From negative infinity to A, also from what? B to infinity. Is everyone good with that? You could also put B to D and, in comma or union, doesn't matter, and D to infinity. That would be basically saying the same thing. Okay, are you guys good on this? Okay, what students get confused by, just making sure you understand, is that increasing and positive is not the same thing. Okay, all right, let me talk about notation here. It doesn't matter if you do open brackets or closed brackets here, so you can actually close these, it'd be fine. But whenever you have an infinity, you must have an open. Okay, that's just the rule, because you can never equal infinity, so you must have an open on the infinity. But otherwise, it doesn't matter if you have an open or closed brackets when they're talking about intervals. Okay, intervals for this, intervals for increasing and decreasing. All right, what are the POIs for f? Okay, how do you find POIs? F double prime positive. So let me write this down and see if this makes sense. We memorized this. This is the first derivative test. Okay, but before our test, we also talked about the concavity test, which actually seems like it should be called the second derivative test. For some reason, it's not. But the concavity test says when f double prime is positive, f prime is increasing and f is concave up. When f double prime is negative, f prime is decreasing and f is concave down. If you move between these two rows, what do you have? A POI. Does it matter if you move from the top row to the bottom row or the bottom row to the top row? Doesn't matter. It's still a POI. Okay? All right, so let me think about this. A POI happens whenever you move between these two rows. Okay? A POI, let me make sure you understand, on F. So this is a POI on F. F is in another room. I don't know where the POIs are in F because I can't see F. But what do I see? I see F prime. And what does this tell me about F prime? What does F prime do? It changes from increasing to decreasing or decreasing to increasing when there's a POI. You guys good with that? Okay, now I want you to, this is the hard part, I want you to look at that and just write it down. Where is F prime changing from increasing to decreasing or decreasing to increasing? Write it down. Let's see if you write down the same thing we write down. I won't call on you, so it's fine, but it's good for you to write it down. Where are the POIs? The POIs are where F prime is changing from increasing to decreasing, or F prime is changing from decreasing to increasing. Okay? You got it down? All the points where you think there are POIs on F. Wherever F prime is changing from increasing to decreasing or decreasing to increasing. All right, let's do it. Here's my finger, okay? It's not my real finger, or my finger. It's not like my bad finger. Okay, here we go. I'm going to go down. I'm decreasing. Did anybody put A? I'm still decreasing, right? But I did change from positive to negative, but I'm still decreasing. I'm decreasing. I'm increasing. Oops, back up. Where is that POI? On E. Did you put E? Okay, there's one answer. All right, let's find another answer. I'm increasing. I'm increasing, I'm increasing, I'm increasing, I'm still increasing, I'm decreasing. Oh, back up. Okay, did you guys put C? Okay, and then where is another point? I'm decreasing, I'm decreasing, I'm decreasing. Oh, I'm increasing. Go back. D. Did you write those 3 points? And if you didn't, try to flesh that in your mind. Why didn't you do it? I'll bet you it's because you said that this is positive and this is still positive. Okay? But remember, we're not talking about f prime being positive. We're talking about is f prime decreasing or increasing. Does that make sense? Okay, yeah.
When we ask the POI, do you always put x equals, or is it just if you don't know what the...
Yeah, it depends what the question is. So usually they'll say, what are the x values where you have a POI? Then you'll put x values. On your test, I think there's a question that says, what is the point of inflection? If they say, what is the point? Then you need an x and a y value. Okay? And so we don't know the y value here, so you wouldn't say it. Okay, everybody good with that? All right, go ahead and pass up your warm-up. Let's do another problem here. This was an AP question from a few years back. And this says you've got this function here. Can you find the point of inflection? So guys, you guys have a quiz tomorrow. I think there might be, I'm not sure, there might be a question like this on the quiz, okay? It's going to be a partner quiz, but you cannot use notes. You cannot use your homework, okay? Nobody else but you and your partner, okay? At what value of the graph is there a POI? So guys, let me rewrite this. X to negative 2 minus x to negative 2, okay? So how do I find a point of inflection? Guys, if they ask you for relative max, relative min, or increasing or decreasing, these are hints that you're going to use the first derivatives test. Are you guys good with that? Okay. If they ask you for concave up, concave down, or POI, these are hints that you're going to use the concavity test. Okay, and please, let me make clear right now. The concavity test is when f double prime is positive, f prime is increasing, f is concave up. When f double prime is negative, f prime is decreasing, f is concave down. All three of these things are synonymous. They're always like, if f double prime is positive, then f prime is always increasing. If f prime is always increasing, then f double prime is positive. If f double prime is positive, then f always has a concave up. Does that make sense? If it's on the same row, they are synonymous with each other, okay? Right here, I use this symbol here for concave up, but I just want to let you know that is not the symbol for concave up. I use it because I'm doing it quickly. Does that make sense? And I want you to see it in like one snapshot, okay? When you're on your test and I ask you if something is concave up, you must write out concave up. Does that make sense? Okay, please do not do this symbol. Because in math, this symbol means something completely different. What does this symbol mean in math? It's a union, okay? So FYI, this is not a symbol for concave up, although it's just shorthand right here so that I can, teach you fairly quickly. All right? If you move between these two rows, though, it's not a relative max or relative min. What is it? It's a point of inflection, okay? And it doesn't matter if you move from top or bottom to the bottom or the top. And that's a concavity test. So when you're asked for a point of inflection, what you're going to do is the second derivative. And you did this on your homework, all right? The second derivative, okay, will be, let me look at this. If I take the first derivative of y, so you see it's negative 2x minus 3 plus 3x minus 4. Can you check me on that? Is that right?
Yeah.
Okay. But I'm going to skip the first derivative test because I want to go to the second derivative test. Because the first derivative test told me nothing about POI. The second derivative is where it's going to help me. So this is going to be 6x minus 4 minus 12x minus 5. Okay. Now the concavity test is just like the first derivative test, but I'm going to do everything with the second derivative. Okay. So just like the first derivative test, I'm going to take this derivative. I'm going to set it equal to what? 0 or what? Or 1 over 0 or d and e. Okay. Then I'm going to solve for x. It's just that instead of calling these my critical points, because critical points are when f prime is equal to 0 or d and e. When I do f double prime equals 0 or d and e, these are called my possible POIs. Okay, just a different terminology, but they're like the critical points for f prime. Okay, so I'm going to solve this. The easiest way to solve this is actually, I think, just get a common denominator. It's not always the easiest, but I think this is going to be easier here. So I'm going to get a common denominator here. So this is going to be x to the 5th on the bottom, and then 6x minus 12 on the top. This will be equal to 0. And over here, it'll be the same because it's the same common denominator. And this will be equal to 1 over 0. All right. Can I cross multiply? I have one fraction on the left, one fraction on the right, and an equal sign in the middle. Yes. Okay. So I'm going to go ahead and cross multiply. If I cross multiply here, this is 0 over 1. So that's going to give me 6x minus 12 is equal to 0. So one possible POI is x equals 2. On this side here, when I cross multiply, I'm going to get x5 is equal to 0. So x is equal to 0. That's a possible POI. So just like the first derivative test, the concavity test, what I do is, I'm hoping that I don't need this anymore. I'm going to write something out. Okay, you're going to do a number line, but instead of doing the f prime number line, what number line will I do? F double prime number line. Okay, instead of putting in my critical points, I will put in my possible POIs. It's the same thing. Okay, it's just different terminology. I need to find a point less than 0. What's a good point less than 0? -1. Okay. So let's put a -1. What's a good point between 0 and 2? 1. What's a good point greater than 2? 212. Very good. Guys are catching on. All right. So guys, I'm going to plug this in, and I just need plus, 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 minus, 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 minus. All right. What function am I going to plug it into? Now I've got 3 functions: f, f prime, and f double prime. Which function am I going to plug this into? F double prime. And guys, that's why it's so important to label the number line, okay? Or else you get so confused, okay? What do you plug in? This is the f double prime number line, so we're going to plug in f double prime. And f double prime, if it makes sense, is this. Let me just clarify. F double prime is this function right here. This is f double prime. Okay, guys, good with that. That's f double prime. You should have that on your paper. All right, so what I'm going to do is plug in -1. If I plug in -1, I get 6 over 1 minus 12 over -1. And I just need to know positive or negative. Is that positive or negative? Positive. So it would be plus plus, right? What if I plug in 1? If I plug in 1, I get 6 over 1 minus 12 over 1. I just need to know, guys, is that positive or negative? Negative. Okay, so this will be negative. And then if I plug in 212, hold on. If I plug in 212, let me factor this. I'm going to factor as 1 over x to the 4th, 6 minus 12 over x. Are you guys okay with that? Because if I remultiply this, if I distribute it, I get the same thing. Okay? So if I plug in 212, is this going to be positive or negative? Positive. If I plug in 212 here, do you see this would just be 12 over 212, which would be something really small, right? So 6 minus this. Would this be positive or negative? Positive. So it's going to be a positive times a positive, which is a positive. All right. Guys, if I were trying to find f prime, this would be increasing, decreasing, or increasing. Does that make sense? Because this is f double prime. So one above that would be f prime. But if I'm trying to find f, then what this tells me, so let me just erase this because I'm not trying to find f prime. I'm trying to find a point of inflection on f. On f, what I have is concave up, concave down, concave up. So where are my POIs? 0 and 2. Okay. What would this have to be for this not to be a POI? If this were concave down, then you would have to have concave down. Does that make sense? If they're both concave down, it doesn't change from concave up to concave down. So therefore, this would not be a POI. Okay, but anyway, right now, what I've got are 0s and 2s are my POI. So what I'm going to write is that x equals 0 is a POI, and x equals 2 is a POI. But when I come up here to look at my multiple choice, okay, this was a test on the AP, a question on the AP test, I actually have both of these as choices. So which one is right? And why do I have both of them? It's 2. Why is it not 0? Can you guys go over here and tell me why? Yeah, because if you plug in 0 here, you're going to get a vertical asymptote, right? Because remember, I don't remember the rhyme, but it goes something like, remove the holes, bottom 0. Vertical asymptote, VAs. To find VAs, you remove the holes. There's no holes here. You set the bottom equal to 0, and that's my vertical asymptote. Well, if I have a vertical asymptote at 0, let me put it at 0. if I have a vertical asymptote at 0, what's happening is that I'll have like, infinities. It's an infinite asymptote. Same thing. Okay. What's going to happen is I don't have a point here. Does that make sense? If you don't have a point, then you can't have a point of inflection. There's no point. I know that's what some of you guys are thinking too. Okay. But if you don't have a point of inflection, you can't have a point of inflection. So therefore, you disregard the 0, and the answer is just 2. Okay. All right. Let's go on then. Learned that yesterday, and this you have to have memorized, so hopefully you have that memorized, that slide right there. And we're going to go to the second derivative test. All right. We're probably not going to have time to talk about your homework, but I posted all the solutions online. If you have any questions about that, I just want to let you know. What did you think about your homework? It's a lot, right? You have one of those on your test. Okay, the one coming up. All right, we'll work on it. One more worksheet like this before your test, so it'll be a little bit more fresh in your mind before your test. But FYI, you'll have something like this on your test. Okay, but we'll do another worksheet like this. All right, what I want to talk to you guys about is the second derivative test. So let me talk to you about it. That's actually not what I wanted. Let me okay. Do you agree that there's a relative max here? Okay. Do you agree there's a relative min here?
Yes.
Do you agree, this is a sharp term, do you agree there's a relative max here? Right, can sharp terms have relative max? Yes. What can they not have though? Derivatives. No derivatives, but they do have relative maxes. All right. There's something special about relative maxes if you think about their slope. What's the slope here?
0.
What's the slope here?
0.
Okay. What's the slope here?
0.
But is this a relative max?
No.
No. Why not? Because remember, slope of 0, superhero. Relative max, relative min, horizontal tangent line. And just to make sure, these are all horizontal tangent lines, okay? But this is a horizontal tangent line with the relative max. This is a horizontal tangent line with the relative min. This is a horizontal tangent line that's neither relative max or relative min, okay? So you can have horizontal tangent lines. You can have slopes of 0 that are not relative maxes and relative min, all right? And the second derivative test, okay, is a test that helps you find, the goal is to find where are the relative maxes and where are the relative min. That's the goal, okay? And we can observe from this is that relative maxes always occur when the derivative is 0. And it always occurs, the relative mins always occur when the derivative is 0. And so let's make sure we understand. The derivative at that point, right? So this is point C, some critical point. This is point C2, some critical point, okay? So if I said to have a relative max, if I wanted to define it, I could say, you know what? I know there is a relative max when the first derivative is 0. But something else has to be true, because it can't just be the first derivative be 0, because all of these have first derivative 0. But what you can also say is if you know the second derivative is negative. You see that concave down, right? So if you know the second derivative at that point is negative, then what you know, and this is what the second derivative test says, let me pull it over a little bit. Okay, this is your justification if you ever have to write a justification for a second derivative test. When you know the first derivative at that point is 0 and the second derivative is less than 0, then you know there is a relative max at that point. Okay, so that is, in a nutshell, your justification anytime you want to show relative max or relative min, and use the second derivative test. Okay, how would I show, do you think, that there's a relative min? The first derivative must be 0, right? What do you think the second derivative has to be? Greater than 0. And if those things are true, then the second derivative test says that you have a relative min. But make sure you understand, it's at a certain critical point. It's at a point. It's not, like you don't have relative min like all along the graph. It's only at that one point. Okay, so that's got to be true. And this is the second derivative test. Okay, so let me clarify that by just showing you the wording on this. So let me see where I have the wording. Here we go. The second derivative test says that if you have a function where the first derivative is 0 and the second derivative exists, okay, on an open interval, not super important that's an open interval, okay, because we really are just trying to find a point, okay, if you have the first derivative 0 and the second derivative greater than 0, okay, let's think about this though. This is where you use what God gave you, okay? God gave all of us like different things that we don't know what they're all for, okay? You know, like your appendix, like what's it for? We don't know, okay? But God gave us all this, okay? He gave Lego men this too, so he gave this to us too, okay? We have this. And what this is the concave up part of this, or concave up. The second derivative is positive. Do you see that? When your second derivative is positive, do you see you have a relative min? Is everybody good with that? Okay? And what students tell me a lot of times is they say when the second derivative is positive and the first derivative is 0, they say that you have a relative max. And the reason students say this is a lot of times we think greater than 0 goes with max. Does that make sense? But it's opposite of what you think. When you have a concave up, okay, when you have a second derivative positive, if you use what God gave you, it's very clear that that is a relative min and not a relative max. Does that make sense? And whenever you have the first derivative 0 and the second derivative less than 0, if you use what God gave you, okay, you'll see that that is not a relative min, but it is a relative max, okay? So I'm just letting you know. Make sure you don't get that confused on the test, okay? Students switch these things up, okay? It's just because intuitively, you always think greater than 0 goes with max. Does that make sense? But if you use what God gave you, okay, you will see that that is actually a min, okay, there. All right, so that's the second derivatives test. I'd like to do homework with you guys. You guys okay with that? Let's look at number 1 through 3. You're going to omit 4, but you're going to do all the rest, okay? Would you like to do 1, 2, or 3?
3.
Okay, let's do 3. So 3 looks like this. Okay, the function is sine x minus cosine x, and the interval is between 0 and 2 pi. Okay? And they're asking you to use the second derivative test to tell me where is the relative max and where is the relative min. All right? For sure, you can use the first derivative test on this. So just FYI, they're forcing you to use the second. Sometimes you have to use the second. So when we look at number 5, if you don't know the function very well, you have to use the second derivative test. Okay? But if you do know the function, you can use either test. All right. The first thing we need to know is to figure out where the critical points are. Figure out where f prime is equal to 0. Because remember, f prime must equal to 0 at that point. So let's see, whatever point we're talking about, C1, it must be 0. And f double prime at that point, whatever point we're talking about, must be either greater than 0 or less than 0. Okay, and this will help us determine, is there a relative max or relative min? That's the second derivative test. Well, first, let me find out what that C is. Okay, it's always at a point. So to find the critical points, what do you have to do? Take the derivative. So what's the derivative of sine x? What's the derivative of cosine x, though? Negative sine x, because it starts with a c, right? C means change the sign. So this is going to be cosine x plus sine x would be equal to 0. Okay, so I take the first derivative, I set it equal to 0. Now we're not going to set it equal to d and e, okay? Because the second, like if you have a d and e on the first derivative, if you take the derivative, you can't get a second derivative on that. Does that make sense? So the second derivative test, you really just need to find the critical point where the slope is 0. You notice, it doesn't say where the slope is d and e. Does that make sense? It's where the slope is 0. So you set this equal to 0, solve for x, okay? Since you guys asked for this problem, it's going to be a little bit harder to solve for x. All right? To solve for x, this means x is some angle where the cosine value is equal to the sine value. Where in your unit circle is there an angle where the cosine value is equal to negative of the sine value? 3 pi over 4. Where else? Right here, 7 pi over 4, right? And we just need to go between 0 and 2 pi. All right, so my answers are x is equal to 3 pi over 4 or 7 pi over 4. Okay, let me go ahead and write the coordinates here. This one's at square root of 2 over 2, comma, negative square root of 2 over 2. And these coordinates here are going to be negative square root of 2 over 2, comma, square root of 2 over 2. All right, so that's the first derivative. So this is what I know. So see if this makes sense. I know that the first derivative I put the point in, 3 pi over 4 is equal to 0. Do you agree with that? Right? And I know that the first derivative at 7 pi over 4 is equal to 0. Right? Because what I did was I set the derivative equal to 0, and I solve for the x's. So that means if I plug in x, I'm going to get 0. You guys good with that? So my next step is going to be to show that the second derivative at 3 pi over 4 is either positive or negative. Does that make sense? And to show that the second derivative at 7 pi over 4 is equal to positive or negative. Well, how do I figure out this second derivative? Take the derivative again. How fun is that? Okay, well, I've got the first derivative here. Oh, I didn't mean to delete that. That's okay. I don't have much room, so I'm going to take the second derivative. So the second derivative is equal to negative sine x plus cosine x. Is that right, guys? Yeah. Okay, so I don't want the derivative of x, though. I want the derivative at 3 pi over 4. So that's going to be negative sine of 3 pi over 4 plus the cosine of 3 pi over 4. Okay, and let me just remind myself over here that at 3 pi over 4, the coordinates are negative square root of 2 over 2, comma, square root of 2 over 2. So when I plug this in, this will be negative square root of 2 over 2 plus negative square root of 2 over 2. So there's a common denominator here. I can add the numerator. So I have negative 2 square root of 2 over 2, which is equal to negative square root of 2. Is that good with that? Is the second derivative at 3 pi over 4 negative or positive? Negative. So therefore, the second derivative test says, you don't have to say that you use the second derivative test. It's not super important. You just need to say the result. Therefore, there's a relative, max or min? Okay, use what God gave you. Concave down, right? Concave down, there's a relative max. Okay, so this would be a relative max at x equals 3 pi over 4. And bam, I'm done with one part. Okay, let me find if there's a max or min at 7 pi over 4. All right, again, I have to take the derivative. So the second derivative, I've already done that. So let me erase this part. And I'm going to plug in not 3 pi over 4 here, but what? 7 pi over 4. So put in 7 pi over 4. So I get negative sine 7 pi over 4 plus cosine 7 pi over 4. Okay. Sine of 7 pi over 4 is negative. So what I get is negative square root of 2 over 2. Cosine is actually positive. So it's positive square root of 2 over 2. And so I get is 2 square root of 2 over 2, which is square root of 2. You guys good with that? So I really just need no positive or negative. Is the second derivative positive or negative? It's positive. So over here, I'm going to say greater than 0. Okay. So here's my justification over here. F prime at that point is 0. F double prime at that point is greater than 0. So therefore, okay, use what God gave you guys. Is there a relative max or a min here? Concave up. Relative max or a min? Min. Okay, so therefore, remember guys, it's opposite of what you think. So relative min at x equals 7 pi over 4, and I'll box it in. That is my justification, and as well as my answer. Okay, any questions on second derivative test? Not terrible, right? Feel like you could do it? Okay, so let me go to number 5. That's going to be terrible. Okay, so let's go to number 5, guys. 5, guys. Okay. Okay, here we go. Number 5, they tell me a whole bunch of things about the function f, and they tell me a whole bunch of things about the function g. The function f and g are two different functions, okay? Number 5a says, write an equation of a tangent line of f. Okay, so we're talking about f here. Write the equation of a tangent line. Guys, you need to know this. You had it on your last test, you had it on this test. Okay, who knows? I might put it on the next test, okay? What two things do you need when you write an equation of a tangent line? Point and slope. So write down point and write down slope. Okay? At this time, we just want to write down the x and y values for a point. Do I have the x value? Read letter A. Yes, what is it? Guys, if I know the x at -1 of f, do I know the y value? Yes, it's written right up here. What is it, guys? 2. So this is going to be -1, 2. It's given to you. If you're not sure where, it's right up here. It's given to you. All right. You need a point on f. You also need a slope on f. You actually need the slope of the tangent line. I need the slope of the tangent line. What is that? It's the derivative. So I need the derivative of, and keep your functions correct, guys. It's still the f function. Okay, I need the derivative of f at negative 1. Do I know what that is?
Yes.
Yes, they actually just give it to you. How nice is that? Okay, they give it right to you. Okay, so what you're going to do is, you've got a point, you've got a slope, you're going to do y minus y is equal to the slope times x minus x, and bam, you are done with part A. Okay, I'm pretty sure you could have done that by yourself. Okay, let's look at part B. Does G have a local maximum or minimum at x equals negative 1? Okay, and right there, what I want to talk to you guys about is this. I'm going to erase part A. Hopefully you're done with it. Okay, is if I use the first derivative test, okay, what you have to do is set G prime equal to 0. And here's my G prime right here. You're going to have to set that equal to 0. Here, set this equal to 0. Then you're going to have to solve for your x's. And what you can get is if something times something equals 0, then what you have is x to the fourth minus 6x third equals 0. Actually, don't write this down, guys. 3f of x plus 2f prime of x is equal to 0. You can get critical points here. I think there's 0 and 6. You can find it. I trust that you could. But over here, we don't know enough about f to get your critical points. Okay, we don't know where the adding these things give you 0. You can't find the critical points here. Okay, and not only can you not find the critical points there, even if I did a number line, even if I did a number like 0 and 6, I would be missing critical points. Does that make sense? And that's a problem, because I need to test in between all the critical points. And even if I try to test in between the critical points, I don't know what f prime, like I don't know the equation for f prime. Does that make sense? So I couldn't even test for it, okay? So first derivatives test doesn't work here, all right? But second derivatives test, although terrible, it will work. So let me show you. What do I mean when I say the second? Well, if I use the second derivative test to find a local maximum, all I have to say at g negative 1 is that g prime at negative 1 is equal to what? Think about the second derivative test. The slope has to be 0, and the second derivative, if I want a local maximum, has to be what? Less than 0, is that right, guys? Then I would have a relative max at x equals negative 1. So I just need to show that. And this is possible to show. It might be a local minimum, though, so it might not be. This one might be greater than 0, and it might be a relative min. Does that make sense? But it's one or the other, okay? And if I can show these two things, then I can show there's a relative max or min. Well, let's show it. Okay, what's g prime at negative 1? Here's my g prime, okay? G prime at negative 1, if I know g prime is just everywhere there's an x, what would you put in? Negative 1. It's not as bad as you think, because if I put in negative 1 here, you see I just get 1. Right? If I put in negative 1 here, that's negative 6 minus negative 1. That would just be plus 6. Do you see that? It's not as bad as you think. Okay? If I put in negative 1 here, do you see that that's just f of negative 1? But do you know f of negative 1? It's what? 2. And so 3 times 2 is 6. If I put in negative 1 here, what's f prime of negative 1? Negative 3, right? Or is it 3? Yeah, negative 3, right? So this will be 2 times negative 3, which is negative 6. So I can actually figure out what g prime of negative 1 is. What is it? It's 7 times 6 minus 6, which is 7 times 0, which is 0. Is everybody good with that? So look, I've already said that g prime of negative 1 is 0. Check. Now I just need to tell the paper. I was going to tell who. I don't know who you would tell. But say that the second derivative is greater than or less than 0. Okay, well, let's see if we can do the second derivative. Well, if you have the first derivative, how do you get the second derivative? Take the derivative of the derivative. Oh, no, it's okay. It's okay. Okay, so we're going to do the second derivative. I'm going to do it with you. You're going to be all right. Okay. What's the derivative of the first? 4x third minus 18x squared. Okay. What's the derivative of, let me move this down a little bit. What's the derivative of the second? You can do it. We've done this before. The derivative of 3 times f of x would just be, 3f prime of x, but don't forget, times the derivative of the inside. What's the derivative of x? 1. So you don't have to put it. I mean, you can. Does that make sense? It's a chain rule, right? Yes.
Why didn't we just derivative the first times the second plus derivative?
It is. You mean right here? Oh, yeah, you can. Okay, we can do that.
No, like, I mean, like,
oh,
no,
no,
not
no,
that.
no, not that. Okay.
Like, for the whole thing, because you did the first part 6, like, the derivative of x to the fourth minus x.
It is. It's a derivative first
And then
times the second. Oh, sorry. Thank you. Thank you. Thank you, Miriam. Okay, I'm so thankful that you did that because we would have gone all the wrong ways. Okay, thank you. Okay, let's do it again. Sorry. Derivative first times the second plus. Guys, you want Miriam on your like helping you with your quiz tomorrow? Just FYI. Okay, derivative first times the second plus derivative of the second. What's the derivative of the second? Now we're gonna do it, right? Okay, it'll be 3 times f prime of x, derivative of the outside, times the derivative of the inside, which is just 1. Okay, plus 2 times the derivative of the outside, guys, this is f double prime of x, times 1. You guys good with that? I kind of ran out of room, but there's still a times 1 there. Okay, derivative, derivative first, and then I also need to multiply by the second. So x4 minus 6x third. Okay, so everybody good with that? I continued on another line. All right, then I don't want g double prime of x. I want g double prime of what? Negative 1. So what you're going to do is you're going to plug in negative 1 to all of these. Okay, so 4 times negative 1 is negative 4. Negative 18 times 1, that's going to be negative 18, I think. Okay, then if I put negative 1 here, guys, and negative 1 here, f of negative 1 is just what? Isn't that negative 3? No, it's 2, thank you. It's 2 plus 2 times f prime of negative 1. That's negative 3, right? But here, guys, do you see that 6 minus 6? So what do you get? 0. So the first term wipes out, okay? Plus, I know you're thinking, well, didn't I know that? Why did I make you guys do that? It's okay. You guys got to do it. Okay, then this term right here, I'm going to plug in negative 1. So what I have is f prime of negative 1, but that's really negative 3, right? So what I have is 3 times negative 3, which is negative 9, plus 2 times, okay, I'm going to put a negative 1 here. So what's the second derivative at negative 1? Is it 5? So that's going to be 2 times 5, which is 10. Okay, do you agree with me so far? And then I just need to plug in the negative 1s here. So that's going to be 1 plus 6. Okay, so what I get here is 0 plus 1 times 7. And so the answer is 7. But really, guys, it's a second derivative. So I really just needed to know what? Positive or negative. So is it positive or negative? It's positive. So what I'll say up here is I'll say the first derivative at negative 1 is 0. The second derivative at negative 1 is greater than 0. So therefore, guys, relative max or relative min? Relative min. Use what God gave you at x equals negative 1. And there's my answer and my justification. Pretty nice. The nice thing is you don't have to do number 5 now. Okay. So the other thing I'd like you to look at is number 12. Okay, well, actually, numbers 7 through 9 are kind of like what we did for the warm-up. Okay, just FYI. So 7 through 9, you're going to look at the picture and you're going to tell me where there's a max and min and stuff based on the first derivative test and the concavity test. Number 12, what you're going to do is they give you a whole bunch of things. This is going to be your hardest. I think you're going to struggle with this the most. They give you a whole bunch of things about the function, and you're going to graph the function the best you can. Okay? If you look at B, what B is saying is that's an even function. Oh, I'm sorry, that's an odd function. Do you guys know what an odd function and even function is? You did it before, right? Okay, so just make sure you understand this. If you plug in negative x, wherever there's an x, you plug in negative x. And if you get the opposite of what you started out with, then this is what's called an odd function, okay? And the sine curve is an odd function, okay? We'll learn a lot more of this in the second semester. But the sine curve is an odd function. If you plug in negative x and you get the exact same y value, okay, that's what we call an even function. And the cosine curve is an even function. Okay, this just means it's symmetric about this is symmetric about the x-axis, right? This one is actually symmetric about the origin. And guys, all this means is that if you fold this and fold it again, that's an odd function. Does that make sense? If you fold it and fold it again, that's your graph, that's an odd function. If you just fold it once, then it's symmetrical, that's an even function, okay? And so what they're going to do on number 12 is they're going to say, you're going to graph the right side, okay? You're going to graph the right side. When you graph the right side, since it's an odd function, you'll get the left side by just doing the symmetry, okay? But on the hint that they give you, A, C, D, E, F, G, you'll do it all for the right side, and then you'll fold it and fold it again. Does that make sense? And you'll get this third quadrant, okay? All right, so good luck on that one. I'll try to put that one online, some hints, but I think it's good for you to think about it. It's actually a good thinking problem. All right, test questions. Did we look at our test at all?